In this module, we're going to discuss how to price forwards on bonds. We saw when we were discussing the binomial model for equities how to price forwards in that case. Well, now we're going to extend that case to pricing forwards in bonds. In the next module, after this one, we'll discuss pricing on futures, and then we'll be able to see an example where forward prices do not equal to futures prices. So here is our familiar short rate lattice. We've seen this now a few times. Short rate begins at 6%. Grows by a factor of 1.25 or falls by a factor of 0.9 in each period. This is the short rate that we're using for all of our pricing examples in these modules. So now we want to price a forward contract on a coupon bearing bond. We're going to assume delivery takes place at t equal to 4 and that the bond that's being delivered is a 2-year 10% coupon bearing bond. We assume delivery takes place just after a coupon has been paid. So how are we going to price this? Or how are we going to compute the forward value? Well, we're going to use risk neutral pricing, and we're going to use what we know about risk neutral pricing. So we know the following. For a generic security, let's say it's got price S at time t, we know the following. We know that S0 over B0 is equal to E0 under Q of Sn over Bn, and this is risk neutral pricing for any security that does not pay coupons or have an intermediate cash flow between times 0 and n. So this is what we want to use to price our forward. How are we going to go from here down to here? That's the question. Well, it's actually very simple. First of all, remember we assumed that B0 is equal to $1. If it wasn't, if B0 was $100, then Bn would be Bn times 100, and we could divide across by the 100 and get back to the case where B0 equals $1. So there's no difficulty seeing that B0 equals $1, or assuming B0 equals $1. Sn, this is the value of the forward contract at time n. Well, what is the value of the forward contract at time n? Well, it's this quantity here. It's Z46 minus G0. This is the payoff of the forward contract. It's the underlying security, which we're calling Z46, minus the forward price, G0. So this is assuming that somebody is long the forward contract. They're buying the security, they're buying it for G0, and they're getting a security that's worth Z46. So this is our Sn. B4 is this quantity here. What about S0 over B0? Well, we know B0 is equal to 1. What is S0? Well, if you recall how a forward contract works, it works as follows. We choose the forward price G0 so that the initial value of the contract is 0. So actually S0 is going to be equal to 0, and so we get this expression here. And now the goal is to figure out what the value of G0 is that makes this true. Well, that's straightforward. This equation implies that the expected value at time 0 of G0 over B4 is equal to the expected value at time 0 of Z46 over B4. As a brief aside, I'll mention, I know I've mentioned this notation a couple of modules ago where I said we'll always use this notation to denote zero coupon bond prices, but here we're going to use it to denote an actual coupon bearing bond price. So we get this expression here, but G0 is a constant at time 0. I know its value at time 0, so I can take this outside the expectation, and I can then bring everything else over to the other side, and I get equation 10 here. So this is the forward price. G0 equals the expected value of Z46 over B4, all divided by the expected value of 1 over B4. Now, if you recall, the expected value of 1 over B4, this is simply, this quantity down here is simply the time 0 price of a zero coupon bond that matures at time 4 and that has face value of $1. This comes from risk neutral pricing again. So this is Z04, and we actually calculated this in the last module. It's actually $77.22 if the face value is $100. If the face value is $1 as we have here, then its price is 0.722. So we actually know the denominator of this expression here. So that means we only need to focus on evaluating the numerator, this. And this is actually very easy to do using our backwards induction or working backwards in the lattice. Let's see how we do that. So to compute Z46, what we will do is we'll work backwards in the lattice from time t equal to 6. So at time t equals to 6, we know that the value Z66 is 110. And it's 110 because at maturity you get the face value of 100 back, but you also get the 10% coupon, which corresponds to $10. So the total payoff at t equals 6 at maturity of the underlying bond is 110. And now we just work backwards at each period to try and find out the value at t equals 4. So for example, the 98.44 here is equal to 1 over 1 plus 0.1055. That is the short rate that prevailed at time t equals 4. So we can see this if we go back to this period here, so 10.55. Times the expected value of the bond 1 period ahead. The bond 1 period ahead will either be 107.19 with probability a half or 110.46 with probability a half. So that's how we get 98.44. Note that we did not include the $10 coupon at this time because we said that the forward contract delivers the bond just after the coupon at this period has been paid. So that's why we don't include the $10 coupon at this period. In contrast, when we're computing the value at t equals 5, we actually would include the $10 that's paid at this period because that actually is a payment to the bond. So we would actually say that the 102.98 equals $10 plus 1 over 1 plus the interest rate of this node times the expected value of the bond 1 period ahead, which is 110. So doing that, we find the value of the bond at t equals 4, and it's given to us here. This is the underlying security of the forward contract. So remember, our goal is to compute the value of this. This is the numerator in the expression for the fair value of the forward price, so I need to compute this expectation here. So we know this is the value at time t equals 4, and I can just work backwards in the lattice and compute its value at time t equals 0. I get 79.83. So therefore, using the expression we have for the fair value of the forward contract, which we see this should have been 10. So we see we're going to get 79.83 divided by 0.722, which gives us a fair forward price, or an arbitrage-free forward price, of 103.38. We can go to the spreadsheet that you have and we can see how these prices were calculated. So as before, these are the parameters for our short rate. So we have initial value of 6% for the short rate, and we see that over the next 5 periods it can grow up as large as 18.31% or be as low as 3.54%. Given the short rate lattice, this enables us to compute the 4-year zero coupon bond price, which we saw earlier at 77.22. Remember, we needed this in the denominator when we were calculating the fair value of the forward price. So the next step to do is to compute the value of the 10% 6-year coupon bond. So recall, it pays off at maturity of $110. This is the principal plus coupon of $10. And then we work backwards to find its value at time t equals 5, including the coupon, which is 10%. Work backwards all the way. And in fact, we can actually find that the value of the 6-year 10% coupon bond at time 0 is 124.14. So we do that here, although we didn't need to do this to compute the forward price. To compute the forward price, we just needed the X coupon price of the bond. So this is the price of the bond at time t equals 4, but these prices include the $10 coupon that's paid at that period. To get the X coupon price, we just subtract $10, and that's what we do down here. So we subtract the coupon, $10, in these cells, and now we can actually work backwards in the lattice to compute that quantity, 79.83 that we saw, and finally we get our value of the forward price, which is 103.38.